Alright, let's talk about section 4.6. 4.6 is over modeling direct variation. When we talk about actually before we even start talking about direct variation, I want to point out that I put a little star up here, and the reason I did is I guarantee you an exam question about direct variation. So in January, there will definitely be a direct variation question. Now, what is it? Direct variation is a situation in which the two variables have a special relationship, either as x increases, so as we look from left to right, the x's get bigger, and the y's increase. So as we move, we're either going positive, positive, or have a increasing slope, or as x decreases, as we move to the left, y decreases, left. As x decreases, y decreases. Alright, interesting. Think of a real world example where this would happen. Well, Mrs. Sturgeon, did you see your arrows? Y cannot go to the left. Y would have to go down. We need to fix that. Decreases. I'm going to take this extra line out. Not particularly a fan. Now, a real world example. Think about it like this. If you work at a job that pays by the hour, when you work more hours, you get more pay. You work less hours, you get less pay. Thanks, Peanut. Less pay. Now, the equation for direct variation is very specific. It says y equals kx. And when we read that, we actually can say y varies directly with x. So y varies directly with x. They're both going to increase. Things to notice. Y is alone, and x is next to a number, k, but nothing else is in the equation. That's it. Just x, y, and k. So the y-intercept, or the b-value of direct variation equations, are always 0. Yeah, the y-intercept, or the b, is always 0. Now this k, it really is the same. It's the exact same thing as slope. So let's remind ourselves about all the things we know about slope. We know that usually we use the letter m, and we know that we can find it on a graph if we do the change in y over the change in x. And our formula, remember, is like this. Now that's for slope. But we just said that our y-intercept is always going to be 0, or the origin. So when we do this problem, if we kind of think of this first point here as being 0 all the time, then really with direct variation, our k value is just going to be the y over the x. Because slope, we would subtract 0, well, that's going to give us the original. Subtract 0, the x, is going to give us the original. That's why we changed the letter. It's because it is slope, but we can find it faster because we don't really need to apply the entire formula. So, I'm going to put a little reminder here. My reminder is going to be that k is just like slope, except now we can really put y sub 2 over x x sub 2. And I'm going to make myself a little note. Because the y-intercept is 0, 0. So this k slope can just be y sub 2 over x sub 2 because the y-intercept is at 0, 0. So what are the things I'm going to ask you to do? The first thing I'm going to ask you to do is to look at an equation and decide whether each of the following items is a direct variation equation. The easiest way to do this is to solve for y. Put it in function form. And then see if your y-intercept is 0. So we do this first problem, we add x to both sides. We now have 0 plus y, which is y, equals x plus 1. This one has a slope of 1 and a y-intercept of 1. So this is not direct variation. Let's try number 2. Put it in function.